The project was extremely complex. We were trying to retrofit modern equipment into a boiler room that was built in 1928. It took a lot of teamwork between the university and ecosystems in order to get the project to work. We replaced 3 aging boilers, we installed a brand new cogen, a 2 megawatt unit, and because it was going inside of the building, we needed to put a sound attenuated enclosure around it. We moved it 3 or 4 times, finally found a spot that worked, and put the whole boiler room together, and the project's been running very well for the last 6 months. The project was extremely complex. We had to work around seasons. Obviously, we can't be taking boilers out when they're providing heat and hot water for the entire campus. So what we wound up doing is, through the first summer when we started the project, we demolished the boilers, replaced the boilers with new, and had them up in time for the fall heating season. We have some small boilers that we were able to operate the campus with through the summer while the project was undertaken. Demolishing boilers from World War II is a complex project. It took quite a bit of time just to get the old boilers out of the way and prepare the space for the new. New boilers went in and online and up and running pretty quickly. In the middle of all this, we were putting up a 100,000 square foot academic building as well, which added to my responsibilities as far as managing projects. Ecosystems did a great job of basically just keeping me in the loop on what was going on, and I didn't have to be on top of it every day. So one of the other problems that added complexity to this project was when we initially looked at our boiler room, it seemed on paper to be pretty simple. We had plenty of room to work. When we started plopping equipment down on the floor plan, we quickly realized we were not going to be able to put everything on the floor. So we had to get a little creative, and Ecosystems came up with a method of building a mezzanine above working height, and we were able to put a lot of the heat exchangers and air handlers for the cogen up on this mezzanine so that we still have adequate space on the floor. Part of the problem is we had to make sure we had adequate clearances for the major maintenances on the cogen. At some point, the generator has to come out and get serviced. The engine comes out and gets a major overhaul. So we needed to maintain clearances in order to move this equipment around on the floor. So therefore, fortunately, having a 25-foot height in the boiler room, we were able to stack equipment up in the air. The savings on the project has been better than we had anticipated in the engineering study. We're currently at an average of about $150,000 per month in savings on our electric bills. We are, even through our winter months, have been down to minimum import from the utility and running almost the entire campus strictly through the cogen. One of the great benefits of the cogen, one of the selling points that I used with the administration, was the fact that we can run the campus in emergency conditions if we don't have incoming utility power. It's a little bit of a process, but I can basically run almost the entire campus just on the cogen if for some reason we lose incoming utility power. So that, combined with standby diesel generators on critical buildings, we have, I consider, 100% resiliency in the electric and power and heat for the campus.